Hello students of class 10, this is your advanced mathematics chapter 3, arithmetic of integers. So in this chapter, first of all we will start from here, page number 100, method of mathematical induction. So in here, let Sn be a statement made for any natural number n such that S1 is true, that is Sn is true for n is equals to 1, and if Sk is true, then Sk plus 1 is also true. That is, if Sn is true for n is equals to k, then it is true for n is equals to k plus 1 also. Then Sn is true for all natural number n. The method of mathematical induction can be seen to be a very much useful in solving certain mathematical problems. Simple application of this method will be discussed now. So example 3.2.1, using the method of induction so that for all n belongs to n, 1 plus 2 plus 3 plus dot 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 plus n, this is equals to n plus 1 by 2. So first of all, in here you see, this is your chapter 3. This is your chapter 3, arithmetic of integers. Arithmetic of integers. Okay, this is your chapter 3, arithmetic of integers. So in here, first of all, example, you see here, example 3.2.1, saying that using the method of induction, so that for all n belongs to n, 1 plus 2 plus 3 plus dot 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 plus n, this is equals to n plus 1 by 2. So in here, look at the solution very carefully. First of all, I will take Sn. Okay, first of all, I will take Sn such that 1 plus 2 plus 3 plus dot 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 plus n is equals to n plus 1 by 2. Okay. So now I will take, this is your first one, let n is equals to 1 I will take. Okay, let n is equals to 1 I will take. So therefore S1, it will be is equals to, this n value 1 I will put it in here. Okay, and I will see if I get the first term or not. N value I will put it in here and I will see if I get the first term or not. So therefore, first of all, in here, this is your 1. Okay, this is your 1 is equals to 1 into 1 plus 1 by 2, which is true. So the following statement is true when n value is 1. The following statement is true when n value is 1. Now I will take n value k. Okay, let n is equals to n value, I will take it as k. So Sk such that 1 plus 2 plus 3 plus dot 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 plus k is equals to k plus 1 by 2 I will get. When n value, when I will give k, then I will get this one. 1 plus 2 plus 3 plus dot 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 plus k is equal to k plus 1 by 2. Understand? This one I will take that this is late, not I will take it as 4. Okay, for n is equals to k. Now I will say it by myself that let Sk be true. Let Sk be true. Yes, let Sk be true. Understand? When n value it is k, then I have said by myself, then the following statement will be true. Therefore, let Sk be true. Now I will take it as n value, I will take it k plus 1. Understand? I will take it as k plus 1, as k plus 1, 1 plus 2 plus 3 plus dot 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 plus k plus 1 is equals to this one k plus 1 into k. This is k, in place of k I will put k plus 1. So therefore k plus 1 plus 1, I will get k plus 2 by 2 I will get. Understand? So in here you see this is a statement there that 1 plus 2 plus 3 plus dot 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 n, it is equals to n plus 1 by 2. I have said that this statement is true when n is equals to 1. I have checked, means not said, I have checked that when n value it is 1, whether this statement is true or not. Now when I give n value 1, the following statement is true. Now I will take n value k. Okay, I will take n value k and I will say that Sk is true. Understand? Sk is true. It means this statement is true when n value is k. Then next I will have to prove. Then the following statement is true if n value is k plus 1. With k if I add 1, then also the following statement will be true. This one I will have to prove. Okay. So therefore, that means this statement I will have to prove that it is true. 1 plus 2 plus 3 plus dot 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 plus k plus 1, it is equals to k plus 1 into k plus 2 by 2. This statement is true. That one I will have to prove it now. So therefore, I will take LHS. Okay, now I will take LHS. This portion I will take. So this is your LHS. This is 1 plus 2 plus 3 plus dot 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 plus, you see, 1 plus 2 plus dot 1 plus 2 plus 3 plus dot 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 plus k I will write. Okay, first of all I will write k up till here, and then plus k plus 1 I will write, plus k plus 1. Understand? LHS. This is the term before this, k plus 1, the term before this. Understand? The term before this term, it will come k, then k plus 1. Okay. So now you see this one, 1 up till here, if you see, then 1 plus 2 plus 3 plus dot 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 plus k, its value is what? Its value is this one. Its value is this one. This value I will put it in here. So this is k plus 1 by 2 plus k plus 1. Okay. If I take LCM here, I will get k plus 1 plus 2k plus 1. This one I will get. From here k plus 1 I will common take, k plus 1 into k plus 2 by 2 I got. And this is equals to what? And this is equals to RHS. This is equals to RHS, this value. K plus 1 into k plus 2 by 2. This is equals to RHS. That means I showed that the following statement is true when n value is k plus 1. Understand? So therefore, last line I can write it in here. This is after I have solved it. The last line I can write it here. Thus Sk plus 1 is also true. Sk plus 1 is also true. Therefore, I can say, you can write this from the book, by method of mathematical induction. Okay, by method of mathematical induction, Sn is true for all n belongs to n. Sn is true for all n belongs to n. Understand? So this is the method of mathematical induction. Now the next example 3.2.2, we will do the next example. So this is your example 3.2.2. Okay. So example 3.2, it is saying that so by the method So by the method of mathematical induction, that 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus dot 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 plus 1 by n plus 1, it is equals to n by n plus 1, n belongs to n. So in here solution, you see, I will take let Sn such that 1 by 1.2 plus 1 by 2.3 plus 1 by 3.4 plus dot 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 plus 1 by n plus 1 is equals to n by uh, n plus 1, n for n belongs to n. Understand? So this is your first. For n is equals to 1, S1 such that um, um, S1 in here, it is the first term, 1 by 1.2, this will be is equals to, in here if I put it, 1 value if I put it, so this will be, okay, this will be 1 by 1 plus 1 is equals to it will get 1 by 2, and this is true, which is true. Okay, which is true. So the following statement is true when n value is 1. The following statement is true when n value is 1. Okay, now next one, for n is equals to k, sk such that 1 by 1.2 plus 1 by 2.3, 1 by 3.4 plus dot 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 plus 1 by k plus 1 is equals to k plus 1 for k belongs to n. Understand? Now I will say it by myself that let sk be true. Okay, so now I will check it for sk plus 1. sk plus 1, 1.2 plus 1 by 2.3 plus 1 by 3.4 plus dot 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 plus 1 by k plus 1, and this will be k plus 1 there. It was k plus 1. So k value, if it is k plus 1, then k plus 1 plus 1. Ultimately, I will get k plus 2. Okay, ultimately I will get here k plus 2, and this will be is equals to k plus 1 by k plus 2 I will get. Okay. So now this one I will have to prove. So I will take LHS here. LHS, this will be 1 by 1.2 plus 1 by 2.3 plus 1 by 3.4 plus dot 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 plus this one. First of all, you write this one 1 by k plus 1 plus 1 by k plus 1 and k plus 2. So this value, this whole value, it is, you see, this whole value, it is k by k plus 1. This one I will put it in here, k by k plus 1 plus 1 by k plus 1 k plus 2. Okay. So now in here, this one, if I take the LCM, I will get k plus 1, k plus 2. So this is k plus 2 plus this will be k plus 2. This will be plus 1. Okay. So this is ultimately is equals to, I will get here, is equals to k square plus 2k plus 1 by k plus 1 k plus 2. Yes, k square plus 2k plus 1, understand, by k plus 1 into k plus 2. Okay, so this is equals to, this is the formula of k plus 1 the whole square by k plus 1 k plus 2. So this one and this one I can cut, so ultimately I will get k plus 1 by k plus 2, and which is equals to your RHS. Okay, which is equals to your RHS. So therefore I can say that, therefore Sk plus 1 is true. Sk plus 1 is true. And therefore the last statement I can write by the method of mathematical induction. Okay, by the method of mathematical induction, Sn is true for all n belongs to n. Understand? Last statement I can write. Therefore by the method of mathematical induction, Sn is true. Okay, Sn is true for all n belongs to n. Means this is the method of mathematical induction. In here you're it is not so much hard, nothing there. This is the statement, this is the statement given it to you. Understand? This is the statement it is given it to you. I have to show that this statement is true for all n belongs to n. That means this is n, natural number, for all n value. Understand? For all natural numbers, this statement is true. So first of all, I will take this whole statement, I will take it as a function Sn such that 1 by this is equals to this for n belongs to n. Now I will say that this statement is true when n value is 1. For n is equals to 1, you see, if one value, if I put it in here, one value if I put it in here, I will have to get the first term. So the first term is 1 by 1 into 2 is equals to, this is, if I put it in here, then I will get 1 by 1 plus 1, which is equals to 1 by 2. So left hand side is equals to right hand side. Yes, left hand side is equals to right hand side. Understand? So therefore, which is true, therefore the following statement is true for n is equals to 1. Understand? The following statement is true for n is equals to 1. Understand? So now I will take for n is equals to n, for n is equals to k. Now I will take n is equals to k. That means k is some natural number. Then this whole statement, it will become this, and I will say that Sk is true. Now I will say that if Sk is true, then Sk plus 1 is also true. That one I will have to show it, that Sk plus 1 is also true. Okay. So Sk plus 1, the statement becomes this, and then I will take the left hand side. Left hand side, it will be, first of all, up till here I will write. Understand? Up till here I will write. That means the preceding term of 1 by k plus 1 into k plus 2, it will be 1 by k plus 1. Okay. Now this value, it is this one. So that one I will put it in here, and I will solve it, and I will try to bring the right hand side, which is this one. I will try to bring the right hand side. I got the right hand side, so that means Sk plus 1 is also true. So therefore I can say that by the method of mathematical induction, Sn is true. Understand? Sn is true for all n belongs to n. Okay. Next you see, next your example, this is your next example, it is example 3.2.3. okay, example 3.2.3. establish the result establish the result 1.2 plus 2.3 plus 3.4 plus dot 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 plus n plus 1 is equals to n into n plus 1 n plus 2 by 3 for all n belongs to n. So in here solution, first of all I will take let Sn such that 1.2 plus 2.3 plus 3 dot these are all multiply going on. Okay, 1 into 2 plus 2 into 3 plus 3 into 4 plus dot 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 n plus 1. This is equals to n plus 1 n plus 2 by 3. Okay, so therefore in here first of all for n is equals to 1, for n is equals to 1. Okay, for n is equals to 1, s1 it will be your 1.2. yes, s1 it will be your 1.2, which is equals to if I put one value in here I will get 1 plus 1 1 plus 2 by 3. Okay, 1 plus 2 by 3 is equals to I will get here, you see 1 into 1 into 2 into 3 by 3. Okay, let me give this instead of multiplication, let me give it dot 1 dot 2 dot 3 by 3. This 3 cut, which is equals to 1 dot 1. So this is equal I got. Yes, left hand side equals to right hand side I got. So therefore which is true? I can say that which is true. Understand? Which is true. So this statement is true for n value 1. Okay, this statement is true for n value 1. Now I will take for n value k. Okay, for n is equals to k, sk it will be 1.2 plus 2.3 plus 3.4 plus dot 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 plus k plus 1. It is equals to k plus 1 k plus 2 by 3. Okay, for n is equals to k, sk such that 1.2 plus 2.3 plus 3.4 plus dot 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 plus k plus 1 is equals to this one. Now I will say it by myself that let sk be true. Let sk be true. Now I will check it for k plus 1. Understand? Sk plus 1, this will be such that 1.2 plus 2.3 plus 3.4 plus dot 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 plus this will be your k plus 1 and k plus 2. Okay, is equals to k plus 1, k plus 2, k plus 3 by 3 become. Understand? Okay. So now I will have to show that sk plus 1 is also true. Understand? That means Sn is true when n value it is k plus 1. So now I will take the LHS. Understand? Now I will take the LHS. Let me show you at the top. Now I will take the LHS. This one I will take the LHS. Now what is our LHS? This is equals to 1.2 plus 2.3 plus 3.4 plus dot 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 plus k plus first of all I will write this one. Okay, k plus 1 plus k plus 1 into k plus 2. Now this value it is already I have said that this is equals to this one. Yes, that one I will put it in here, is equals to k plus 1 k plus 2 by 3 plus k plus 1 into k plus 2. Understand? This is equals to I will have to bring this one. Yes, this is equals to I will have to bring the right hand side of k plus 1. This one I will have to bring. So in here if I take the LCM, I will get k plus 1 k plus 2 plus thrice k plus 1 k plus 2. Now from here k plus 1 and k plus 2 I can take it common. So k plus 1, k plus 2, k plus 3 by 3, and which is equals to our RHS So thus I can say that thus sk plus 1 is also true. Thus I can say thus sk plus 1 is also true. Therefore, by the method of mathematical induction, Sn is true for all n belongs to n. This one I can write. Therefore, by the method of mathematical induction, Sn is true for all n belongs to n. Okay. So next you see, next it is example number, next you see 3.2.4. Okay, 3.2.4. Applying the method of induction, so that a plus ar square plus dot 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 plus arn is equals to a rn plus 1 minus 1 by r minus 1, n belongs to n, r not equals to 1. Okay, so this is your solution. First of all, I will take let Sn such that a plus ar plus ar square plus dot 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 plus arn is equals to a rn plus 1 minus 1 by r minus 1 for n belongs to n and r not equals to 1. Understand? So in this series, you see, this is a geometric series. Okay, this is in geometric progression. This is GP. Understand? So its first term will be this one. Its first term. Okay, so in here the first term will be this one. A plus AR. This will be the first term. So in here, number 1, for n is equals to 1, S1, okay, S1 such that A plus AR, okay, A plus AR is equals to, okay, A plus AR is equals to, this is your A R 1 plus 1 minus 1 by R minus 1 is equals to, it will be a r square minus 1 by r minus 1. So this is a r plus 1. This is a square minus b square formula. Okay, a square minus b square formula. So this is equals to, you will get here a r plus a. Understand? So you can say which is true. Understand? Which is true. Yes, LH is equals to RH is you got, which is true. Finished? Now I will have to take n value k I will take. Okay, n value k I will take. So this one, let me rub it in here. Okay. Okay, let me do it in the right hand side. This is which is true. Now I will take for n is equals to k I will take. Okay, for n, this is n belongs to n and r not equals to 1, For n is equals to k, this is, you see, sk such that a plus ar square plus dot 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 plus ar k, okay, a r to the power k is equals to, in here, a r k plus 1 minus 1 by r minus 1. Okay, for sk. Now I will take that let sk be true. This one by ourselves I will say that sk is true. Now I will check for sk plus 1. Understand? Now next I will check for sk plus 1. Now let me rub it. Now I will check it for this is your number 3, sk plus 1. It will be a plus ar plus ar square plus dot 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 plus ark plus 1 is equals to ark plus 2 minus 1 by r minus 1. Okay, now I will take the LHS. LHS, this will be a plus ar plus ar square plus dot 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 plus, first of all I will write up till here, ark plus ark plus 1, yes, is equals to, now up till here you see this value, up till here this value is this one, yes, this value is this one I will put it in here, ark plus 1 minus 1 by r minus 1 plus ark plus 1. Understand? Ark plus 1. So now in here you see this one is equals to, in here LCM I will take, this is r minus 1, ark plus 1 minus 1 plus ark plus 1, and this will be your r minus 1. So this is ark plus 1 minus 1 plus r. This is, if I multiply with r, this one I will get k plus 2 here minus ark plus 1. Okay. By, this is r minus 1. Now this is equals to ark plus 1 minus a plus ark plus 2 minus ark plus 1. This one and this one, it will cancel out, and by this is r minus 1. Okay, so now this one what I got here is that if I take a common here, I will get ark plus 2 minus 1 by r minus 1, and this is equals to RHS. Look, this is equals to RHS. Understand? This is equals to, I got RHS. Yes, so therefore what I got? Therefore I got it. Therefore I can say that sk plus 1 is also true. Sk plus 1 is also true. So last line I can write, therefore by the method, for all n belongs to n. Understand? Sn is true for all n belongs to for all n belongs to n. Understand? Okay. Next I will go to example 3.2.5. Okay, example 3.2.5. So now in your solution, first of all I will take let Sn such that 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 is equals to n square, where n belongs to n. For n is equals to 1, I will get S1 such that the first term is 1 is equals to, and this will be 1 the whole square, and which is true. Next I will take for n is equals to k, sk such that 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 is equals to k square, where k belongs to n. Okay, where k belongs to n, I will take that let sk be true. Let sk be true. Okay, now I will take it. This is your first one. This is your first one. This is your second one. Now third, I will take it sk plus 1. So 1 plus 3 plus 5 plus dot 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 plus, this will be 2k plus 1 minus 1 is equals to k plus 1 the whole square. Okay, k plus 1 the whole square. So now I will take the LHS. I will have to prove that sk plus 1 is also true. I saw that S1 is true. Sk I have taken it to be true. Now I will prove that sk plus 1 is also true. So I will take the left hand side. 1 plus 3 plus 5 plus dot 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 plus this one I will get this one is 2k plus 2 minus 1. So 1 plus 3 plus 5, let me write it in this way. 1 plus 3 plus 5 plus dot 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 plus, first of all I will write this one, 2k minus 1 plus this, it will become 2k plus 2, 2 minus 1, 1 only become 2k plus 1. So up till here the value it is k square. So this one I will put k square plus 2k plus 1, and this is k plus 1 the whole square formula, which is equals to RHS. Thus I can say that sk plus 1 is also true. Sk plus 1 is also true. Okay, so therefore last line I can write is that by the method of induction, Sn is true for all n belongs to n. Okay, I can write the last line. By the method of induction, Sn is true for n belongs to n. Okay. Next I will do question number 2. Next in here I will do question number 2. This is 2 plus 4 plus 6 plus dot 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 plus 2n is equals to n plus 1, where n belongs to n. So in here, first of all, I will take let Sn such that 2 plus 4 plus 6 plus dot 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 plus 2n is equals to n plus 1 for n belongs to n. For n is equals to 1, S1, this is 2, is equals to, if I put 1 here, 1 plus 1 is equals to 2. So therefore S1 is true. Next I will take for n is equals to k, Sk such that 2 plus 4 plus 6 plus dot 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 plus 2k is equals to k plus 1 for k belongs to n. I will take it by myself that let Sk be true. Let Sk be true. Now last one I will take Sk plus 1. 2 plus 4 plus 6 plus dot 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 plus 2k plus 1 is equals to k plus 1 into k plus 2 become. Now I will have to prove that Sk plus 1 is also true. In order to do that, I will take LHS 2 plus 4 plus 6 plus dot 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 plus, first of all I will write 2k plus this, it will become 2k plus 2. So up till here the value it is this one. Yes, it is this one. So this value I will put k plus 1. Let me this one, let me, no need to multiply it, keep it in this way. So plus 2k plus 1. Okay, so from here k plus 1 I will take common, k plus 1, k plus 2, which is equals to I got RHS, which is equals to I got RHS. So therefore I can write that Sk plus 1 is also true. Therefore I can write, by the method of mathematical induction, Sn is true for n belongs to n. Okay, next I will go to question number 3. So this is question number 3. 1 square plus 2 square plus 3 square plus dot 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 plus n square. This is equals to n plus 1, 2n plus 1 by 6 for n belongs to n. So this is solution. First of all, what I will do, I will take let Sn such that 1 square plus 2 square plus 3 square plus dot 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 plus n square is equals to n plus 1 twice n plus 1 by 6. N belongs to n. For n is equals to 1, S1 such that this is 1 square is equals to, this is 1 plus 1 2 dot 1 plus 1 by 6, which gives me 2. This one it will be 3. So this one it gives me 2 dot 3 by 6. So this is ultimately I will get 1. Okay, this is ultimately I will get 1. So therefore I can say that S1 is true. Left hand side equals to right hand side I got. Therefore S1 is true. This is 1. Next I will take for n is equals to k. For n is equals to k, I will take Sk such that 1 square plus 2 square plus 3 square plus dot 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 plus k square is equals to k plus 1, 2k plus 1 by 6 for k belongs to natural number. Now I will tell that let Sk be true. Let Sk be true. Last one I will take Sk plus 1 such that 1 square plus 2 square plus 3 square plus dot 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 plus k plus 1 the whole square is equals to k plus 1 into k plus 2 into, if I give here 2k plus 1, I will get this is 2k plus 1 plus 1, 2k plus 2 plus 1, 2k plus 3 I will get. So this is 2k plus 3 by 6. Okay, now I will take the left hand side. Understand? Now I will take the left hand side. Okay, so in here I will have to rub it, top part I will rub it. So this one you see I will take the left hand side. Left hand side it is first of all 1 square plus 2 square plus 3 square plus dot 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 plus first of all k square plus, then I will write this one, k plus 1 the whole square. So up till here the value it is what? Up till here the value it is this one. Yes, the value it is this one. That I will put it in here, k plus 1, 2k plus 1 by 6 plus k plus 1 the whole square. I will have to show that this is equals to this one. This is equals to this one. Okay. So now in here what I will do, it is k plus 1, 2k plus 1 plus 6 k plus 1 the whole square by 6. Okay. So in here I can take k plus 1 common. K plus 1 I can take common. So this one I will get k 2k plus 1 plus 6k plus 1 by 6. So this is k plus 1. This one it will be 2k square plus k plus 6k plus 6 by 6. Okay, so this one let me solve it, is equals to again k plus 1. This one it will be 2k square plus 7k, 2k square plus 7k plus 6 by 6, k plus 1. This one if I splitting the middle term, if I do 6 to the 12, 2 6 2 3 3 1. So this is 4 2k square plus 4k plus 3k plus 6 by 6. Okay, so this is equals to k plus 1. From here I can take 2k common, k plus 2, 3 common, k plus 2 by 6. So this is equals to k plus 1. This one I will get k plus 2 and 2k plus 3 by 6 I will get, and which is equals to, this is equals to what? This is equals to RHS. Understand? This is equals to RHS. Okay, understand this whole thing? It is equals to what? It is equals to RHS. Understand? So therefore I can say that therefore SK plus 1 is also true. SK plus 1 is also true. Therefore SN is true. Therefore by the method of mathematical induction, SN is true. SN is true for n belongs to n. Okay,